Hello guys, this is Paul McWhorter from TopTechBoy.com, and we are here today with lesson number 46 in our incredible tutorial series where you are learning artificial intelligence on the Jetson Nano. I need you to pour yourself a nice big mug of iced coffee, and I need you to get ready to learn some cool new stuff. So let's go ahead and let's get out our Jetson Nano gear. And as you are getting out your Jetson Nano gear, as always, I want to give a shout out to you guys who are helping me out over at Patreon. Your generosity is keeping this great content coming. You guys that are not helping out yet, look in the description down below. There is a link over to my Patreon account. Think about hopping on over there and hooking a brother up. But enough of this shameless self-promotion. Let's jump in and let's talk about what we are going to learn today. If I remember correctly, and I do think I do, I had given you a homework assignment in lesson number 45. And that was that, if I remember right, in 44, we were able to launch both cameras, the webcam and the PyCam. But the problem is, if we just sort of did it sequentially with logical programming, while we are updating or grabbing a frame from the webcam, the frames are backing up on the PyCam. And so what your assignment was to use what you learned in lesson 45, which was threading in classes, to create a program that would allow you to run both cameras at the same time where they were running in sync. Were you guys able to do that? Man, hopefully you were able to get two cameras. I understand that those Logitech webcams went from like $60 to like $250 because everybody all of a sudden is at home video conferencing or something because of the lockdown. But hopefully you guys are able to scrounge up two cameras, because this is really important, what we're learning here, because it's more important than running two cameras. It's learning how to do things where they run synchronously, and that is what we're going to need to do as we move forward in artificial intelligence. Okay, let me get out of your way here, and let's come over here and let's launch a fresh new Visual Studio Code. And then we are going to be creating a new program. So we are going to come here, and if I remember right, we are operating in the face recognizer folder, and we're going to create a new file. And I believe we are on program 11, and I think I will call this twincam.py like that. All right. I try to label things both sequentially with a number and also something that if I come back later I can remember what the program does. Okay. So now what we are going to want to do is we are going to want to run both cameras where they're in sync, which means we're going to have to do it with a class and do it with threading. So we're going to have to do a little bookkeeping here. And the first thing that we are going to want to do is we are going to know that we're going to be threading, because that's kind of the objective here of this program. So we better from threading import thread. Make sure you get your case right. Little t on the threading and big T on the thread. We also know that we will be doing CV2, so we better import CV2. And then you never know when you might want to put a delay in, so we better import time. Okay, this should all look pretty familiar to you. Now, we are going to do this using a class, okay? And so we will create a class, and each class, this class is going to manage a camera. Okay, so this class is going to manage a camera, so I'm going to call it vStream. Okay, like that. Now, if we think, what do we want this class to do? We want it to launch a camera, and then we want it to sit and collect frames, and then we want to make a way where the user down in the main program could run up and grab a frame. So the user down here in the main program, when he creates an object with this vStream name, we want to launch a camera, and then we want to sit and take frames. And then the guy down here, he needs to be able to go up and grab a frame from that camera whenever he wants. Go up and grab a frame from that camera whenever he wants. Now the camera is constantly, the class is going to have a thread that is constantly gathering frames, constantly taking frames, but down here is the main user and the main part of the program. You can just go grab one when you need it. Okay, so you just grab one when you need it. So those are three things: launch the camera, grab frames, and make frames available. Okay, what is the one part of that you want to do one time? Launch the camera. You only want to do that one time. So where would you do that? You would do that in the init. Okay, so let's just come down here to the main program before we do anything else. So what would this be? This would be like, I would create cam1, okay, and in the past, cam1 was like cv2.video capture of, like, for the webcam, the number 1. So what I want to do is I want to say cam1 is equal to, but instead of calling the cv2 video capture, I'm going to create the cam1 in this class vStream. So I'm going to say that it is vStream1. So I'm going to create an object, cam1. It is of the class vStream, and I'm going to pass the vStream a 1. So I don't grab I don't grab it in the class name, right? I grab that parameter in the init. So now I've got to define the init method. And remember, what is a method? It's a function that's inside of a class. So a method is the same as a function. So we are going to do the init underscore underscore init underscore underscore, and then always we pass it self. Well, in this case, what is self? It's going to be cam1 because that's what called it. So anytime I see self, in this case, it's going to be cam1. So I got to pass it self. And then I need to know what the source is. What camera? Well, it's camera 1, so we're going to call that SRC. So now SRC is going to have the value 1, and self is going to have the value cam1. Does that make sense? Now, what do we want to do? Well, we want to launch the camera. So self, which is cam1, then I'll just call it something self.capture. I got to call it something self.capture. What is that going to do? If we want to launch the camera, what do we need to do? video capture, and then SRC. What is SRC? It's 1, because I passed 1 into SRC, and then I'm putting that there, and now that is going to launch the webcam, and the webcam is going to be known as cam1.capture. Okay? Now, what do we need to do also in the init? Well, we're going to want to be taking frames, so we're going to want to launch a thread. Okay? So we're going to say self.thread. So what is self? Cam1. Cam1.thread is equal to thread. And then what are we going to target? I got to target something. I got to target self.update. Okay, what is update? We haven't defined it yet. All right. So I want a thread that will sit and just continuously read a frame from cam1. So I'm going to target another method, which I'm going to call update. Well, I haven't created that yet, so I better come down here. And this is very bad. I didn't put my colon there. And now I got to tab indent that. Okay. Now, I need to define what? I need to define update. And what do I pass update? Self. What is self? Self is cam1. Now, what am I going to do in update? I want to just continuously read frames. So if I'm going to continuously read frames inside of here, I'm going to need a while loop. So while true, what am I going to do? I'm going to read the camera. So remember, when you do camera read, it returns two parameters. The first one we're just going to throw into the underscore, which we'll just throw away. And then we're going to call it self.frame. Now, why not just call it frame? Because if I have a cam 1 and a cam 2 and they're both reading into frame, then frame is going to be having data coming from two different places. So I'm going to call it self.frame. So if it's cam 1 doing it, it'll be cam1.frame. If it's cam 2, it'll be cam2.frame. Okay, and then this is equal to self.capture.read, like that. So what is my camera? My camera is cam1.capture. What am I going to do to cam1.capture? It's read. Why do I say cam1.capture? Because I created the object cam1 in the class vStream. Okay, when I come up here, self is going to be cam1, and then I said cam1.capture is launching the camera. And so here, if I want to read from it, what was my camera? It was cam1.capture. Okay, from here to here makes that cam1.capture, and then I read from it. So then this should start looking like our old friend, that CV2 read command. Okay, so now I have a frame. Okay, what is the problem? The problem is it's going to just sit there and read it. But also, I created a target for the thread, but there's a couple of other thread things I need to do. I need this thread to play nicely with the other threads, so I'm going to say .daemon equal true. That means it plays nice with its neighbors, and when you kill the overall program, it should kill the threads. And now I need to start it. Self.thread.start. Okay, so now cam1 comes to vStream. It launches the camera. It defines a thread, which is targeted here, and then it tells that thread to behave nicely, and then it starts the thread. So what I should have now is I should have a constant supply of cam1.frames. Whenever I want one, I got to be able to go and grab it. So I've got to define something that allows me to grab the frame. So that will be a define get frame. Now get frame is not going to be called from inside the class. It's going to be called down here in the main program. Whenever I want a frame, I will just call get frame. And then get frame is going to be a very simple thing. It needs, like everything else, to have self. And then what is it going to do? It is just going to return what? Self.frame. Okay, so if I give a call of cam1.getFrame, it's going to go out and grab the frame from cam1. If I say cam2.getFrame, it's going to grab the frame from cam2. All right, so this should, anytime it's called, launch a camera and then just sit and continuously take frames, and then when this is called, it'll offer up the latest frame. So now I have created cam1, so I will also need to create cam2, which is going to be equal to vStream. I want this to be the Raspberry Pi camera, so I'll call that camset. And remember, from all those programs we've done, we've got to define camset. And so the best way to do that is to go to one of your old programs, which almost every single one of your old programs should have that camset defined in it. So just go get your camset from wherever is the most convenient place. I've got to have a camset here somewhere. I tell you how easy it is. Let's just do it the better way. Let's go to our www.toptechboy.com. We'll come here. Okay, I will go to, I think I can just restore it. Go to www.toptechboy.com, and then you'll want to come to this lesson, starting the Raspberry Pi camera or a web camera on Jetson Nano. You can do that by searching on that. You guys should know this now. And then it's this cam set command that I need. That one line. I don't need to copy the whole program. I'll grab that, and then I will come over here, and I shouldn't have started all of these crazy things. Okay, so we're back to twin cam, and I'll get this out of the way. So now what I'm going to do is I'm going to define cam set, and then remember there were 3 parameters that cam set needs, and one is your flip method. For me, flip equal 2 to make the image right side up, and then display width was 640 and display height equal 480, and then it goes in and puts those numbers in this long string that it's creating to be able to launch the Raspberry Pi camera. So now flip to that. So this should launch the camera. So at this point, what I should have is I should have both cameras launched, Cam 1 and Cam 2, the webcam and the Raspberry Pi camera. They should both be launched, and they should both be generating frames. One is going to be generating a Cam 1 frame and the other a Cam 2 frame. And I should be able to get either or by then calling either cam1.getFrame or cam2.getFrame. Okay, so what we will need to do here is we will need to come in and create a loop, and that loop is going to be while true. And normally we would just go and operate in the while true, but what can happen is it can take a little time to run out and get these things launched and get the thread going, and you don't want to read a frame before it's there, so I need to do a try and except. And what try is, it just creates a loop, and when you're looping in the try loop, if there's an error, it just drops to the bottom and tries again. And so if we try to do a couple of reads and there's no frame, rather than the program crashing, it'll just come up and try again. And so this is an indented. So what do I want to get? Well, I want to get my frame, and I want to get that from the webcam. So how would I do that? Well, that is cam1, and then what method do I call? It's already, the frame is already up there. I just got to go get it with getFrame. Okay, so getFrame. Okay, and it will know to give me the cam1 frame. All right, because I'm calling it as cam1. Now I'll call that frame 1. Now I also want to get my other frame, so that would be my frame 2 would be what? It would be cam2.getFrame. This is not getting the frame from the camera, this is getting the frame from the class, because the class is sitting there with that thread constantly generating them, and I just get one when I want it. Okay, now I should do cv2.im show. And what do I want to show? I want to show the web cam, and then that would be my frame 1. And then I also want to do a cv2.im show, and this would be the Pi cam. And then what would I want to show there? My frame 2. Is this kind of logical? Cam 1, Cam 2, operating through the class vStream. I can get what I want, which is Cam 1 in the method getFrame, or Cam 2 in the method getFrame. Now if I was going to do a Cam 3, I would have to come up here and I would have to launch another instance of that vStream of Cam 3. All right, now if you do a try, you want to do an except, and this is just what happens if you do hit an error. It jumps down to except, and what I will do is I'll just say print frame not available. And usually when you first run this, you'll get 3 or 4 frames not available, so it tries to read, and then all the threads get launched and everything, and then it'll start reading them. But if I don't do it this way, the thing will crash out. All right, now what do we also want to do? Remember our old exit gracefully, so it would be cv2.wait key 1. It's going to look for the ord of Q for quit, and we've done this no telling how many times, so I don't need to keep repeating myself on that. But what you got to think is, now if you quit, what do you need to do? You need to release what? You need to release, you need to do a cam1.capture.release, right? Because what is my camera? It's cam1, and then when it's created, it creates it as cam1.capture. So what is it that I need to release? I need to release cam1.capture. And similarly, I need to do a cam2.capture.release, like that. And then I do believe that I will need to also destroy all windows. And let me get a little better view for myself. So then I would need to do a cv2.destroy all windows. I'm going kind of fast. Also, just for good measure, I'm going to do an exit 1, and that should kind of help kill all that threading business in a nice way. And then once I've done all that, I want to break out of this while loop, and then that will kind of end the program. Okay, this stuff you should be fairly familiar with. This exit might be a new command I'm throwing at you, but that just kind of helps you get out of those threads. All right, so now let's run this thing and see what happens. Okay, up 8 vstream. Oh, I misspelled update up here. Hopefully you guys caught that. Update. That's the target for that thread, which is update. Okay, let's try again. All right, look at that. Now I've created 2 windows. The real question though is it like, are they in sync or not? 1, 2, 3. Look at that. Perfect sync. No latency between those 2 windows. Boom! The magic of threading, the power of classes. Look at that. Perfect sync on those 2 windows. All right, what do I not like? I mean, first of all, that's the hard stuff that I've gotten done. So I've got this cam 1 running, I've got this cam 2 running, and then they're staying in sync because I'm doing it with threading in classes. Okay, let's quit out of this. What I do not like is I do not like that I got a big window and I got a little window. Okay, what I would like to have is I would like to have one window that has both images in it. One window, both images. Okay, so going to have to make this a little snazzy, and so if I'm going to combine those 2 pictures, I need NumPy because I got to start treating the picture as an array, and I'm going to use some NumPy commands. So I'm going to import NumPy as np. Okay, and so now also, did you notice that one image was bigger than the other? I need them to be the same size if I'm going to put them in the same window. And so what I need to do is I need to pass to this init, I need to pass it the width, and I need to pass it the height. Okay, now why do I need to do this? Now that cam set has got the width and height in it, and I'm launching that camera for the size that I want, which is the width and the height, or the display W and display height. The problem is this particular webcam that I'm using, I can't set the height. It just sort of returns it to me, is 640 by 480, so I'm going to have to resize it to the right size. But since I just have one class, I'm going to resize them both. Really, the Cam 1, the Raspberry Pi camera doesn't need to be resized, but it doesn't hurt to resize it. So I'm going to pass it width and height. Okay. Now, what I'm going to need to do is width and height is what's coming in. Now I've got to define the self.width and the self.height so it can be used, in all the parts of this class. So I'm going to say self.width. This is the parameter that's going to be used throughout the class. That's going to be equal to width. Okay. And then I'm going to say self.height is equal to height. Now, anywhere else, like if I want the cam1.width, I can use cam1.width, which would be self.width. All right. So now that sets things up, I think, very nicely. I'm passing it source, I'm passing it width, I'm passing it height. And then here, when I grab the frame, what am I going to do? I'm going to take self.frame, and that is going to be equal to cv2.resize. And then what do I want to resize? Self.frame. So if it's cam1, it would be cam1 frame. If it's cam2, it's cam2 frame. And then I'm going to resize it to what? Self.width and self.height. And remember, that's a tuple, so that needs to be inside of its own set of parentheses. All right. And now when I return self.frame, it is going to be the resized one. So it's going to try to resize the PiCam image, but it's going to resize it from 640/480 to 640/480. And then the other one, it's going to be whatever that larger size was, probably 800 by 600. It's going to resize it down. So the bottom line is, at the end of this, they should both be the same size. Okay, but when I call it now, when I create that cam1, instead of passing it one parameter, I need to pass it 3 parameters. So then this would be what? Comma. Well, I've already defined the display width, and so I'll pass it display width, comma, display height, and then I'm going to pass it, comma, display width, comma, display height. Does that make sense? All right. Now, I think if I just run this, it's going to be just like before, only they should be the same size. Let's just, for good measure, make sure that this works. Okay, look at that. Getting a little bit of strange behavior there, and that's on the webcam. It's going back and forth. So let me quit out of that and see why that was doing that. So I say get frame, my frame 1, my frame 2. I've destroyed them there. Cam1.capture release, cam2.capture release. I did self.frame resize. So for some reason, what I need to do is I probably need to say self.frame 2, because if I call this after this has done, but before this has done, it's going to return a big frame. And so to kind of keep them synchronized, I need to return frame 2. And so this is self.frame 2 is always going to be the small one. I think that'll fix that little ugly problem. That kind of surprised me. I wasn't expecting that. Ah, look at that. Boom. Do you see that? 2 cameras in sync. 2 cameras in sync. That is really great. Okay, but what I don't like is I don't like that they're in separate windows, because I want to start working with these things together. Okay, so now what I want to do, I want to put them in one window. And so what I will do down here is I'm going to create a new frame, which is going to be my frame 3. And what my frame 3 is going to be is it is going to be NumPy. I'm going to start treating that my frame 1 and my frame 2 as NumPy arrays, and I want to stack them together. I want to horizontally stack those two arrays together. So I'm going to do it with NumPy. I want to horizontally stack them, which is H stack. What do I want to horizontally stack? I want to horizontally stack, and I've got to make it a tuple. Frame 1, comma, frame 2. Now make sure you see this. Horizontal stack is the NP command, but it wants a tuple. So notice that there is an extra set of parentheses there. If you don't do that, it's not going to work, and you're going to go crazy trying to figure out why it doesn't work. Now I only am going to do one IM show, and that is going to be, I'm going to IM show that frame 3 that I just made. So now I'm also going to be a good boy, and I'm going to say cv2.move window. And what do I want to move? This will be, instead of webcam, we're going to call it combo cam. And I'm going to move combo cam to 0, 0. And I don't think that's a tuple. I think that's just a 0, 0. And so let's run this and see what happens. Getting a lot of frame not availables, which is sort of concerning to me. And so something is not working. What did I do wrong? Let's look at this. My frame 3 is np .hstack, np.hstack, and then I'm going to stack frame 1, and I'm going to stack frame 2. That sure looks right. Ah, look at that. It's that combo cam. Like that. Did you guys catch that? Run Python file in terminal. I just spilled water on myself. I mean coffee. And it still does not like this. Okay, so we got to do a little debugging here. My frame 3. This was working just a second ago. Make sure it knows what NumPy is. We imported NumPy as NP. Okay, so I got to find where my error is, and the problem is there's an error, and when there's an error it just comes down here and it says frame not available. So I'm going to take that print out, and I'm just going to say pass, and so maybe I'll see an error before it goes down into that except. So now we're going to say run Python file, and I'm looking for an error here, and that is sort of my frame 3 is my frame. Ooh, oh my goodness. Oh my goodness. Were you guys screaming at me? Rookie mistake. My frame. Oh, that was probably painful to watch. That was probably painful to watch. All right. Now I'm going to go back and I'm going to put my print back in. I think this one's going to work this time. Run Python file in terminal. Try it again. Darn it. I think maybe, okay, frame not available, frame not available. I'm wondering if we've got that problem that when I was playing around crashing the camera, if perhaps, I'm going to try one more time, perhaps I've got those cameras locked up, and let's just see if we close this. Sometimes closing the Visual Studio will release the cameras. Open it back. And now let's run it. We were so close. Okay, boom. That was it. So I didn't have an error. It's just I'd locked those cameras up. So look at that. One window. Do you see how there's just, I don't see any perceptible latency between those two cameras. They are both running. Boom. Combo cam up and running quite nicely. Okay, running quite nicely. You see that? Now, if you look at me in the actual, stream, you can see that those two cameras maybe have a quarter-second latency, but that is really good. But the main thing is they're in sync with each other, and it looks to me like that sync is pretty much perfect. All right, so that is pretty darn good. You know what, guys? This is a long lesson, but we're going to do one more thing. The thing that starts mattering at this point is you want to know how fast you're running. And so as we start doing optimizations, what we are going to need to know is we're going to need to know how fast it's running, because right now it's really easy because all it's doing is grabbing frames and combining them and showing. Grab show is real easy, but in the future lessons we're going to go back and start doing the image recognition and the facial recognition again. So we really need to kind of instrument this thing so we know what kind of frames per second we're getting. And so in order to do that, what we are going to do is we are going to instrument this so that we can see what our frames per second is. And so in order to do that, we're going to put some timers in here. And so before we go into that while loop, I'm just going to start a timer. So I'm going to say start time. I'm going to grab the time here, and I'm going to say that that is going to be time. So that's kind of like the present time. I'm grabbing a marker there. And also we are going to be putting some text on that combo image. So what I need to do is I need to create a font, and that is going to be CV2 dot font underscore Hershey underscore simplex, because we're going to need that later on. Okay, I think that is what we need. And then we got to put some timers down here in our loop. So what I will do is I am going to say that dt is equal to, dt, the change in time, is equal to the present time, time, that's the present time, minus what? Start time. And that will be how long it took to do these steps. Okay? And now what I want to do though is I want to go ahead and grab the start time for the next time around. I've got how long it took to go through the loop the first time, but now I got to grab another start time, which I will use next time around. So I will say start time is equal to time. And so that'll be sitting there for use next time around. And now I am going to create a low pass filter. And so I will say the DT average, I've got a DT, but I want a DT average. I'm going to say that that's equal to 0.9 times the old DT average plus 0.1 times the new DT. And so if I get a crazy DT, I don't trust that last measurement. I only give it a 10% weight. I really trust that kind of running average, but then I sort of fold in that new data. All right, and the key thing to a low pass filter is this and this need to add to 1. Okay, so if I kind of trust the new data coming in, I could make this a lot more. If I don't trust it at all, I would make it less. And so you're kind of trading off how snappy it is with how accurate it is. But this should be about right. So now I've got the kind of running average of the frames per second after going through a low pass filter. And look at some of my earlier lessons on low pass filter if you don't understand that. Now I want to create the frames per second. Well, if it takes 1/10 of a second to go through this loop, if it takes 1/10 of a second to go through the loop, how many times a second could I go through the loop? 10. If it takes 1/100th of a second, I could go through it 100. So frames per second is equal to 1 divided by the change in time average, that low pass filtered value. All right, now I need to create a little background rectangle that I can, well, before I do that, let me just do a print frames per second just to see if I'm getting it. Let's see how fast we're running. So we'll come up here and run Python file in terminal. Did not like font Hershey Simplex. It missed the second underscore there. That was easy enough. Okay, there it is, but it is not printing frames per second. So let me quit and see, why did it not do that? That is most unusual. You know why it must? I know why. It was erroring out, and it was erroring out because the first time through the loop, DTAV does not have a value, and so I've got to start that DTAV equals 0. So it was saying DTAV. I don't know what DTAV is. It's an error, but it didn't crash because it's in a while loop, so it was just constantly crashing at that point and going to the except. So now let's run Python file in terminal. I think it's going to run this time. Okay, look at that. All right, and look at this. It seems like that it would be willing to try to run at, it looks like maybe something like 100 frames per second. Now what you got to realize though is that the camera isn't running that fast. It's going through the loop that fast. So that would mean probably in some of the times through the loop, I'm grabbing the same frame. I like grab the frame, go through the loop, and grab the frame, and there's not a new frame, so it's just grabbing the old frame. So I'm not really operating that fast. I'm going through the loop that fast. But that's very good that I can go through the loop that fast. Now what I want to do, though, is I want to, let's see, I want to put that on, the image. So what I'm going to do is I'm going to say, I'm not going to print it, but what I'm going to do is I'm going to put a little rectangle on the image. So I'll say cv2.rectangle, and I want to put it on what image? My frame 3. And then I want to go from the upper left corner, which is going to be 0, 0. All right. And then I'm going to go, let's say, over about 100 and down about 40. And this is just going to be the background for my text that I'm going to put on there. And so now I need to give it a color. So let's give it red. So we'll call it 0, 0, 255. Remember, it's blue, green, red. And then I wanted a solid rectangle, so I put -1 for the line thickness. So that would be a solid red rectangle in the upper left of the frame. Now on that, I'm going to run this thing just to make sure I don't have an error there. Hopefully I can make a rectangle, and I cannot, in fact. And again, I'm getting this frame not available, meaning that I am erroring out in that loop. So what mistake did I make in that rectangle command? So cv2.rectangle, I'm putting it on frame 3. I'm going from 0, 0, to, darn it, rectangle with an L. How about that? Rectangle. Did you guys find that? Did you guys see me make that mistake? Okay. Okay, and it's not crashing, but I am not getting a rectangle on there. So let's quit. And let's see. Oh, I did it. I did it. I did it after the I am show. So I need to take this I am show and move window. And I need to put it after that. And now this time it will show. Okay. All right. So I'm going to, all these calculations are right, but it's just I should have done the rectangle before I do the show, or it won't show. So let's try it again. Okay, there's my little rectangle up there. And now I want to put some text in it. And so what do I want to do? I want to do a CV2 dot put text. And then where do I want to put the text? On my frame 3. And then what do I want to put? Well, I want to put the string of frames per second. But the problem is that frames per second has like 50 decimal points, so I want to round that off. So I'm going to round the frames per second, okay, to 1 decimal place. And let's be careful of our parentheses, okay. That parentheses closes the round, and then that parentheses closes the string, and then I should, after I close those two, I should put a comma, and then I'm going to, let me also to that string add the tag space FPS for frames per second. And now, where do I want to put that? I want to put it at 0 in the X, 0 in the X, and then I want to put it like in the Y down 25, so it's not like off the screen. I want to bring it down a little bit so you can see it. And then I want it to be font, which we already defined. I want it to be about 7.75 high. And then I need to give it a color. I want it yellow, which will be 0, 255, 255. And then a heaviness of 2. And then close out all my parentheses. What is the chance I put that in right without a mistake? Okay, let's run this. And a couple of frames not available, and boom. Okay, now what you can see is that this is working, and we're getting, even with the low pass filter, we're getting a lot of variation in that frames per second being recorded. But what you can see is that I can run through that loop a lot quicker than the frame can update. So the camera is operating at like 30 frames per second, and I'm running through that loop really, really fast, and so I'm kind of getting noise up there in the frames per second data. But what's going to happen now when we go in and start doing the image recognition, or the face detection and the face recognition, it's going to slow it down. But what we have now is we have a framework where we can look at that frame per second, and we can start kind of optimizing how we do the face detection and face recognition. So what your homework is for next week is to take this framework that we developed today, this program that we've just developed, and in next week's lesson, or your homework for next week is going to be to go in and apply facial recognition to this image, where basically you're going to box your face here and identify who you are, and box your face here. So you're going to do facial recognition on both of those images, and you're going to box them from both cameras. Now, in reality, this one camera might be pointing at me and the other camera might be pointing at someone else, but you've got to, in this window, identify the faces, find the faces, and then identify them. Does that make sense? Okay, that will be your homework for next week, and then we will come back next week and see how to go through it. All right, hopefully you guys are having fun. Again, we are doing low latency, we are doing classes, and we are doing threading, and we're getting something pretty cool coming out of it. Hopefully you enjoyed this lesson. Paul McWhorter from TopTechBoy.com. I will talk to you guys later.